one more problem that I want to present to you, which I also found on Facebook. Now, this one is quite interesting because it has a lot of possible solutions to solve here, but we're only pertaining to one thing. The problem that I found looks like this. So imagine there is a circle here and there is a given angle of 120 degrees within POQ, O being the center of the circle. Now, we are trying to find angle T, which is opposite of this central angle. Now, for this particular problem, I'm going to present not one, but two possible solutions. Now, if you are well versed with circle theorems, this is one of those situations. Okay? Now, for this particular problem, the circle theorem that I'm going to use, well, I'm just going to structure it in a certain formula so that everyone can understand. Looks like this. So if you have an external angle, it is crossed either two secants, a secant and a tangent, and a two tangent line scenario, the formula will look like this. So x is equal to 1/2 the difference of A and B, where A is what we call the major arc and B is the minor arc. Okay? So in order to get the angle, I have to take the difference of the major arc and the minor arc and then divide it by 2. So that's the very idea. So the major arc that we're going to solve is this part. Okay, this large part here. The minor arc, of course, that's the smaller one here. Now, how do we figure out the major arc? Now, take note that the circle in whole is 360 degrees. Since already taken the 120, so we'll just have to subtract it from 360 in order to get the major arc. In this case, if I subtract 360 by 120, that will be equal to 240 degrees. So that will be the larger side of PQ. Okay? So this will serve as your A, and this will serve as your B. Like so. So to find the angle X, in this case, that will be the measurement of angle T. Okay? So the measurement of angle T will be equal to 1/2. The major arc will be 240 minus the minor arc, which is 120. Now, if I subtract these two, you will always get 120, right? And then 120 is divided by 2. So the measurement of angle T is 60 degrees. Clever, right? Okay. But what if you're not familiar with circle theorems? That will be a problem, right? Okay. So, there is an alternative if we're going to solve this even without knowing the circle theorems. If you can't do it with circle theorems, you can do it with right triangles. Oh, what? Right triangles? How can I do that? Okay. Let's go with the alternative. Okay, so we will take this out and this out. Okay, so without the consideration of the circle, we could do this. We will use the technique of angle bisector and right triangles. Okay, how are we going to do that? Okay, first, we need to bisect angle T exactly at the middle up to its opposite side. Now, of course, because angle T is opposite to angle O, 120 will also be split into 2. So let's take this in. And 120 now becomes 60 here and 60 here. So for angle T, you will have T over 2 here and you have T over 2 here. So it's spliced at the middle. Okay? Now, you said right triangles, right? So we need a right angle. Okay, one property of circles is if you have a radius and it is pointed on one of the tangent lines, it will always be perpendicular. If it's perpendicular, then you have 90 degrees. So, you'll have a 90-degree angle at this point and this point. Excuse my drawing. Now, we have created a right triangle on either side, from here or here. So let's take out one of the right triangles and it will look like this. So let's take the bottom at this point. Okay. So this angle is T over 2. So we can say the measurement of angle T all over 2. And this one is 60 degrees. Okay. So we will now use the property of right triangles. If not with right triangles, at least for an ordinary triangle, right? So at this point, we could use the sum of the interior angles. Now, according to the sum of interior angles of a triangle, the sum of which is 180 degrees. So the sum of these three angles will always be equal to 180 degrees. Okay, having said that, so this measurement of angle T over 2 plus 60, then this perpendicular angle is always 90 degrees, so we'll just have to add 90 degrees is equal to 180 degrees. Or, there's also an option that since this is 90 degrees, the remaining angles will be complementary. So, that's further simplified as the measurement of angle T over 2 plus 60 is equal to 90 degrees. Of course, there's also the fact that if I transpose 90 degrees on the other side, that'll be 180 minus 90, you'll get 90 degrees. So, the complementary side can also work here. Now, what else do we have to do here? So, we need to isolate the measurement of angle T. We still have a 60 here, so we can transpose it to 90. So, that will be 90 minus 60, you will get 30 degrees. So, the measurement of angle T over 2 will become 30 degrees. But I need the measurement of angle T only. So what do? I multiply 30 by 2. So, the measurement of angle T is simply equal to 60, which is previously solved from the first method. So, even if you do not know the circle theorems, this is a better alternative. Okay. I guess you have interest with geometry now. I hope. Well, thanks to that, and this is Mega Vinx, signing off.